Hello seekers, today we're going to derive this equation. The topic is energy density for plane progressive wave, and already derived this equation. Y is equal to a sine 2 pi by lambda Vt minus x. This is the equation of plane progressive wave, and we consider a particle in the medium, a very small unit volume V, and density of the medium rho. So mass per unit volume is also rho. So rho is equal to mass upon volume, and we take the volume as unity. So we can say that kinetic energy will be equal to 1 by 2 mv square, and Ke is equal to 1 by 2 mv square, which will be equal to 1 by 2. Mass is, rho is equal to mass upon volume, and mass is equal to volume into rho. So volume into rho into velocity square. Okay. So volume is 1, we don't need to write volume, and rho b square. Okay. So rho is rho, and b square means dy by dt square. It's y is the displacement. So we will put the value of y here. Okay, and then derivative it. Then let's see what we get. So first we have to do the derivative and do its square then. So kinetic energy will be equal to 1 by 2 rho and dy by dt. So d big bracket a, sorry, curly bracket a sine 2 pi by lambda bt minus x, curly bracket close, divided by dt, and all this square. Okay, so this will be equal to 1 by 2 is 1 by 2, rho is rho, and when we do the derivative of this with respect to t, we get a is a, and sine, the derivative of sine is cos 2 pi by lambda bt minus x. Okay, and when we do chain rule and do the derivative of this with respect to t, we get 2 pi by lambda into b. Okay, and this square, and we will get 1 by 2 rho a square, from here b square into 4 pi square by lambda square cos square 2 pi by lambda bt minus x. Okay, so now I think something will be cancelled out, like 2 to the 4. Okay, 2 times 2 is 4, so it gets cancelled out, and rho a square v square lambda square, so nothing gets cancelled out now. So we can write like this: 2 pi square v square rho square, sorry, rho not square, a square upon lambda square cos square 2 pi by lambda bt minus x. Okay, let's say this is equation number 2. Oh no, sorry, 1. We have not made any equation, so this is equation number 1. Okay, now we'll write this is equation number 1, and now we'll find out the force on the media, which will be equal to ma, and we know that mass is equal to rho into b, as b is constant. Mass is equal to density, and density will be equal to density into acceleration will be equal to d square by second derivative of displacement. Okay, we know that. Remember, this is not the dy by dt of whole square. This is this second order derivative. So this will be equal to rho and 4 pi square v square rho square, lambda square a sine 2 pi by lambda bt minus x. Okay, I just write it directly. You can calculate, but this is very simple. Like, okay, it's just simple. Like, you have to just put the value of y, and then 2 pi by lambda will come out as constant, and the derivative of 2 pi by lambda bt minus x, the angle will be v only. So when you do 2 times, it will come 2 times. Those are like 2 times 2 will be 4, and pi times pi will be pi square, v times v will be v square, and At the down, uh, there will be lambda square. Now I will calculate for work done, and work done will be equal to force into displacement. Okay, so work done for small displacement dy of the layer will be equal to force between a force, that is rho 4 pi square v square by lambda square a sine 2 pi by lambda bt minus x. Okay, and we know displacement dy is we take for very small displacement, so the displacement will be dy. So now work done or complete displacement. Okay, complete displacement uh, from 0 to y. We just integrate this from 0 to y. Okay, when we integrate this, we will get 4 pi square v square by lambda square will be come out, and 0 from integration from 0 to y with respect to dy will be uh, only this will remain. Okay, we know that is y is equal to a sine 2 pi by lambda bt minus x, so this will be y, and we will replace this by y. Okay, so integration from 0 to y with respect to y will be y square by 2, so it will be equal to 4 pi square v square by lambda square into y square by 2. Okay, now this 2 and 2 times 2 is 4, it will cancel out, so we'll get the expression like 2 pi square v square y square lambda square. Okay, this will be the work done for complete displacement from 0 to y. Okay, as we got this work done, now we will substitute the value of y again in this equation. So work done will be 2 pi square v square rho and lambda square, and the square of y is a square sine square 2 pi by lambda bt minus x, and the work done will be 2 pi square a square v square rho lambda square, and I just write it like in arranging terms, nothing more than that. Okay, since potential energy per unit volume of the particle in the medium is equal to work done. Okay, potential energy per unit volume is one, of the particle in the medium is equal to work done. So potential energy will also be equal to this 2 pi square a square v square rho by lambda square times sine square 2 pi by lambda vt minus x. Okay, I hope you will understand and say it equation number 2. So now total energy. Okay, total energy will be per unit volume. Okay, we are only talking about per unit volume. Its volume is unity. We already derived kinetic energy in equation number 1. So we already derived equation number 1 and 2. So total energy will be the sum of kinetic energy and potential energy. So we'll take 2 pi square a square v square rho by lambda square common. Okay, then we'll get 2 pi square v square rho square. Sorry, rho is not square. Okay, so a square only, and lambda square is common, so remaining is cos square 2 pi by lambda bt minus x. Okay, plus sine square 2 pi by lambda bt minus x, and cos square x plus sine square x is 1, so we can write total energy is equal to 2 pi square b square rho a square by lambda square, and this will be equal to 2 pi square n square a square rho. Okay, this is the final expression for total energy. Energy will be equal to 2 pi square n square a square rho is n, or v is equal to n lambda, as n is frequency. We know that. Okay, Then total energy per unit volume of the medium. We should say total energy per unit volume of the medium as we're talking about volume from the early. Okay, from the start we are talking about the volume, so we should say like total energy per unit volume of the medium will be equal to 2 pi square n square a square rho. Okay, where pi is 2 pi is constant, n is frequency, a is amplitude, and rho is the density of the particle or the medium. Sorry, medium. Also, total energy will be equal to 1 by 2 rho a square omega square. Okay, we know that omega is equal to 2 pi by t, or omega is equal to 2 pi by t, or omega is equal to 2 pi n. Okay, we write omega is equal to 2 pi n here, 2 pi n. So, what we'll get is 1 by 2 omega square, 2 pi square n square is equal to 1 by 2 omega square. Okay. So we derive total energy per unit volume is equal to 2 pi square n square a square rho energy density. So total energy per unit volume is energy density, which will be equal to 1 by 2 rho square a square omega square. We already derived this. Now there is a small topic which is called energy current. Okay, what is energy current? I will write here. Okay, the rate of flow of energy per second per unit area along the direction of propagation of wave is called energy current or energy flux of the wave. Okay, and this will be equal to EV is equal to 2 rho pi square a square n square v, and we just multiply with v is velocity. Okay, uh, I will tell you like dimensionally, and you will remember it correctly, like v is distance upon time, velocity is distance upon time, and what are we told in the derivation is rate of flow of energy per second per unit area. Okay, per second per unit area means the per second means say t, we get per second t. Okay, and per unit area means a. Okay, and remember this only talks about the energy, but this energy is energy density, so energy upon volume, this is energy upon volume. Okay, so this only talks about energy. So if we like energy, this is energy, which in dimension will be ml t square l ml square t power t square. Okay, minus 2, t will be minus 2. We don't need that, so we don't write that. And energy upon volume is say volume. Okay, and this is energy upon volume is energy density. And when we multiply this with the velocity, like velocity is distance upon time, and say distance is l upon time is t. Okay, what we get is this, like if we cancel out l with b, we get area. Okay, you know that as volume is l into l into l, and area is l into l. Okay, so we get l, so this will be equal to energy in denominator and in numerator time multiplied by area. Okay, and this is the definition of energy current. I hope you understood these things. We should see dimensionally, and we will actually know the definition then. Uh, the rate of flow of energy. Rate of flow of energy means energy per second per unit area, means per second per unit area, per second per unit area. Rate of flow of energy per second per unit area along the direction of propagation of wave is called current, energy current, or energy density. Okay, so if we multiply the energy density with velocity, we get this energy current. Okay, I hope you understood that, and I'm sorry that my English is a little poor, but I hope you got it, and you got it when you will actually write it in your copy. So please write it 2-3 times, and then you can clearly understand this topic. This is very easy topic. Okay, thank you.